Hello students, welcome you once again to GK's maths classes. Today we are going to do relations and functions and problems based on relation. This is the part 4 of the video of relations, where we will be doing more problems in relations from NCERT as well as from questions from outside. So I hope these videos are very useful. I will definitely be putting the link of part 1 to part 3 in the description box so that you can always refer to it. Okay, so we'll straight away get inside the problem. The first question is, give an example of a relation which is symmetric but neither reflexive nor symmetric, transitive but neither reflexive nor symmetric, and there are 5 subdivisions in that. Okay, so we have to do this problem. It's a very important question. Not that all the subdivision will be asked, maybe 1 or 2 subdivision can be asked for 1 mark, or it can be asked for 2 marks. Okay, now already we have explained what symmetric and what is reflexive and what is transitive relation is. So if you have still doubt in that, you can refer to part 1 of this videos, where I have explained in detail what is symmetric, skew-symmetric, symmetric, transitive and reflexive relation is. Okay, so I will not be wasting my time on again explaining what is symmetric, what is reflexive and what is transitive. So let us see how to go about it. So for what I will do here is, first I will take a set A which comprises of elements say 1, 2, 3. I will take set A which comprises of element 1, 2, 3. Then what I will do, I will try to find A cross A. My A cross A will be 1, 1, 1, 2, 1, 3. Then it is 2, 1, 2, 2 and 2, 3, followed by 3, 1, 3, 2 and 3, 3. Fair enough, isn't it? So this is A cross A. And your relation, I am going to define a relation R on A. That means R is a relation from A to A. That means R is going to be a subset of A cross A. Okay. So here I want to talk about symmetric, a relation which is symmetric but neither reflexive nor transitive. So the first subdivision. So I will take a relation R from this subset. Let's, for example, if I take 1, 2, 1, 2, definitely I should have 2, 1, only then it is symmetric. Because you know, for symmetric relation, for every A belongs to S, A, A belongs to R, that is for reflexive, correct? For symmetric, for every A, B belongs to S, A, B belongs to R, then you can say B, A also should belong to R. And for transitive, if you take 3 elements A, B, C in R, in S, then AB belongs to R, BC belongs to R, then you can say A, C should also belong to R. So this is the basic definition of reflexive, symmetric and transitive relation. So now here, if I have a relation like this, say 1, 2 and 2, 1, it cannot be reflexive because I don't have 1, 1, 2, 2, 3, 3. If I had 1, 1, 2, 2, 3, 3, then this condition will be satisfied, then it will become reflexive. Since I don't have 1, 1, I don't have 2, 2 and I don't have 3, 3, this is not a reflexive relation. So it is not reflexive. Now let us see whether it is transitive. If I have 1, 2 in R, which is true, and 2, 1 is also in R, which is true, then 1, 1 should be in R. But 1, 1 is not in R. Therefore, this condition is not satisfied. Therefore, it is not transitive. Whereas if you see carefully, if A, B belongs to R, that is, if 1, 2 is in R, 2, 1 is also in R. Therefore, this is a perfect example of a relation which is symmetric, but not reflexive, not transitive. I hope this is clear. Okay. Let's go to the second example. Now, what is my second example? I need a relation which is transitive, but neither reflexive nor symmetric. I need a relation which is transitive, but neither reflexive nor symmetric. Let's see. Let me choose R. I'll simply write 2, 3, a single element. 2, 3. If you remember, if you refer to my video 1 of relations, I also gave you an alternate definition of transitive. It is not necessary that if AB belongs to R and BC belongs to R, then only AC should belong to R. If AB belongs to R is true and BC belongs to R is true, then AC should also belong to R. Otherwise, if you have only AB belongs to R and I have no clue about what BC is doing, if I have only AB belongs to R, I can simply say it is transitive. So here if you notice 2, 3 belongs to R and I don't have 3, anything. If I had say 3, 2 also belongs to R, then I can talk about 2, 2. But here I don't have to do all that because A, B belongs to R. That itself is sufficient to say it is transitive. So here you don't have to give this definition where AB belongs to R, BC belongs to R, then AC also belongs to R. So only if these two are true, then AC belongs to R should be true. But if you don't have B, C belongs to R, it is sufficient to say A, B belongs to R to prove it is transitive. So this is an example of a relation which is only transitive. It is not reflexive because 1, 1, 2, 2, 3, 3 is not there, and it is not symmetric because if 2, 3 is in R, you should have 3, 2. You don't have 3, 2 here, so it cannot be symmetric. Okay. Now let's go to the third example. Now what is the third example? Reflexive and symmetric but not transitive. It has to be reflexive. So let's exhaust that. You should have 1, 1. Definitely you should have 2, 2. Definitely you should have 3, 3. That satisfies the reflexive condition. So this relation will always be reflexive. Now is it symmetric? If you want it symmetric, let me add one of the elements from here. Any one element, whatever you like. So I will choose 1, 2. If I add 1, 2, then the question is it reflexive? Yes. Is it symmetric? Definitely no, because if 1, 2 belongs to R, you should have 2, 1. So to make it symmetric, I need to add 2, 1. Okay. So this is definitely reflexive. This is definitely symmetric. But is it transitive? That also you should need to verify. Is it transitive? 1, 2 belongs to R. 2, 1 belongs to R. 1, 1 belongs to R. Correct? You can try one more. 2, 1, 1, 1. I think this is a relation which is reflexive, which is symmetric, and it is also satisfying the condition of transitive. So this is not a correct example for reflexive, symmetric, but not transitive. So for not transitive, what I will do, since by adding 1, 2, I am not able to establish it, I will add one more element. So I will add 1, 3. Again, is it reflexive? Yes. Is it symmetric? Definitely no. Why? I added 1, 3. I need 3, 1 to make it symmetric. But is it transitive? That's a question that we need to answer. Is it transitive means, for example, you have 2, 1 belongs to R, correct? You have 2, 1 belongs to R. And you have 1, 3 belongs to R. So these two conditions are satisfied. Then definitely 2, 3 should belong to R. But 2, 3 is not in R. So this is a perfect example of a relation which is reflexive, which is symmetric, but definitely not transitive. Okay. So I can just say this is a perfect example of a relation which is reflexive and symmetric, but not transitive. Okay. We'll go to the next page. Okay. Let me just select this and keep it there. I may need it. Just a second. Yeah. So I may, whenever I want, I can just refer to it. Okay. Now, what about reflexive? I need a relation which is reflexive and transitive, but not symmetric. Reflexive and transitive, but not symmetric. So let us take a relation R. This is the fourth subdivision. It has to be reflexive. So it has to be 1, 1. It has to be 2, 2, and it should have 3, 3. This is reflexive. And I will add one more element to it. Say, for example, I will add 2, 3. Is it reflexive? Yes. Is it symmetric? Definitely no. Definitely it is not symmetric. Is it transitive? 2 comma 2, 2 comma 3. It works. So this is a very perfect example of a relation which is reflexive and transitive, but not symmetric. You see, 1 1 2 2 3 3 belongs to R, it is reflexive. If you choose 2 comma 3 belongs to R, and if you take 3 comma 3 belongs to R, you have 2 comma 3 belongs to R. So this is perfect example of a relation which is reflexive and transitive, but definitely not symmetric because 3 comma 2 is not in R. Okay? So I don't need this, so it is confusing, so I'll write this off. Now the fourth subdivision. What is the fifth subdivision now? This is too thick, I feel. Okay, fifth subdivision. What is the fifth subdivision? Symmetric and transitive, but not reflexive. So first let us establish the fact it is symmetric. So 1 comma 2 means definitely I should have 2 comma 1. Am I right? So it is definitely symmetric. The question is it transitive? Definitely no. If it has to be transitive, I need one more element. What is that? 1 comma 1. So that 1 comma 2 is in R, 2 comma 1 is in R, 1 comma 1 is in R. So this is symmetric. It is definitely transitive, but it is not symmetric, it is not reflexive because 2 comma 2 and 3 comma 3 is not in R. 2 comma 2, 3 comma 3 is not in R, and it is definitely symmetric because A comma B belongs to R, B comma A belongs to R. It is definitely transitive because AB belongs to R, BC belongs to R, AC also belongs to R. So this is an example of a relation which is symmetric, transitive, but not reflexive. So I have given an example with one situation, with one set. I have covered all the subdivisions. If you want, you can give other examples like parallel to, perpendicular to, is less than, greater than. You can decide how you want to give an example. But this is a case where I took one set and I give an example for all the 5 subdivisions so that it is easy to remember. Remember, there is no particular procedure to do this problem. You have to argue within yourself and question the definition and see whether the definition is satisfied or not. If it doesn't satisfy, then it is not reflexive or symmetric or not transitive. The only confusion people may have is in the second subdivision. Please understand, for only transitive, you just have to have A comma B belongs to R. You don't have to have B comma C belong, not necessary. If it is there, if AB is there and BC is there, then only AC should belong to R. Otherwise, if you have only AB belongs to R, it can be taken as transitive. Okay. I hope that is clear. Now let's go to the next question. All these are, the previous one is also an NCERT question. This is also an NCERT question. And these are all very, very important questions. It's an MCQ question also. R is a relation on the set A, that is 1, 2, 3, 4. There are 4 elements. I gave you example with 5 elements. Okay. I gave you example with 3 elements. And they have given you a relation R. Now I have to decide whether it is reflexive, symmetric or transitive. If it has to be reflexive, since there are 4 elements, I need 1, 1, 2, 2, 3, 3, 4, 4. Identify. 1, 1, 2, 2, 3, 3, 4, 4. Therefore, definitely this is reflexive. Okay. Now we have to check whether it is symmetric or not. 1, 2 is that, search for 2, 1. 1, 2 is that, 2, 1. 2, 1 is not there. So it is not symmetric. Now you have to check whether it is transitive or not. For example, if you take 3 comma 2, 3 comma 2 belongs to R, and let us take 2 comma 2 belongs to R. Therefore, 3 comma 2 belongs to R. So it is it's transitive for this case. Let me try one more if you want. 1 comma 3 belongs to R. 3 comma 2 belongs to R. Obviously, 1 comma 2 belongs to R. So this is a relation which is reflexive, not symmetric, but it is transitive. So you need to argue the problem like this. You can't have a method like A equal to B, squaring both sides. No, you don't have a procedure. You have to analyze the definition. You take the definition and analyze it. Then you will automatically get the answer. Okay, so this is an example of a relation which is reflexive and transitive but not symmetric. This is option B. I hope this is clear to you. Now this is the next very nice problem. It's again an NCERT worked out example question. Let A equal to 1, 2, 3. Then show that the number of relations containing 1, 2 and 2, 3 which are reflexive and transitive but not symmetric. Okay. So let us take first relation. Since we don't know how, since it is already said there will be 3 such relations, so I call the first relation as R1, and let us first figure out reflexive. Reflexive means definitely it should have 1, 1, it should have 2, 2, and it should have 3, 3. Okay, 1, 1, 2, 2, and 3. And by the question, he has said it is compulsory to have 1, 2, and 2, 3. He has said it is definitely necessary that you should have 1, 2, and 2, 3. Is it reflexive? Yes, it is reflexive. Is it symmetric? Definitely it is not symmetric, because 1, 2 is there, means you should have 2, 1. Since 2, 1 is not there, it is definitely not symmetric. Good, well done. Now what I should do? I should search for transitive. Is it transitive? It is not transitive as of now, because if you have 1, 2 belongs to R, and if you have 2, 3 belongs to R, both belongs to R, definitely I should find 1, 3 belongs to R if you want the relation to be transitive. So what I will do? I will add 1, 3. So this is example of a relation which is reflexive and transitive but not symmetric. So this is one such relation with 1, 2, 3. Now let's take the next relation, R2. So you will have 1, 1, 2, 2, 3, 3, 1, and by the condition you should have 1, 2 and 2, 3. Yes, and because it has to be transitive, definitely you should have 1, 3. Definitely you should have 1, 3. Now is it reflexive? Yes, it is reflexive. Is it symmetric? Definitely not symmetric, because 2, 1 is not there, 3, 2 is not there, 3, 1 is, even if 1 is not there, it's not symmetric. 1. This is reflexive. This is not symmetric. Is it transitive? We have to figure out. Is it transitive? 3, 1 belongs to R. 1, 2 belongs to R. Correct? 3, 1 belongs to R. 1, 2 belongs to R. Definitely 3, 2 does not belong to R. So definitely this is an example of a relation which is reflexive, which is not symmetric and transitive, and it is different from this. This is R1 and this is R2. So let us take R3. You should have definitely 1, 1, you should have 2, 2, you should have 3, 3 for it to be reflexive, and by the question you should have 1, 2 and you should have 2, 3, and because 1, 2 and 2, 3 is there, you should have 1, 3. Okay, so now this is an example of a relation which is reflexive and transitive but not symmetric. Now what I will do, I'll add some other elements. Say for example, I'll add 3, 2. I added 3, 1. Now I'll just add 3, 2. Is it reflexive? Yes. Okay. Is it symmetric? Definitely no. 2, 3, 3, 2. That may work. 2, 3, 3, 2. It may work, just like this case. But 1, 2 is there. 2, 1 is not there. Since 2, 1 is not there, it cannot be symmetric. Now, is it reflexive? You can say 2, 3, 3, 2, it works. 1, 3, 3, 2, 1, 2, it works. So, I think it satisfies the definition of transitive. 1, 2, 2, 3, 1, 3. 1, 3 is there. 2, 3, 3, 2, 2, 2. It's there. So, I think this is transitive. So, this is an example. Third relation, which is reflexive, not symmetric, but transitive. Okay. So, I hope this is clear. So, how many relations are there? R1, R2 and R3. Again, you can't do these problems as a method. You need to understand, you need to argue, understand the definition of reflexive, symmetric, transitive, then only you can do these problems. Okay. The next question. This is again an NCERT question. A equal to 1, 2, 3. Find the number of relations containing 1, 2, 1, 3 which are reflexive and symmetric but not transitive. Let me talk about R1. You have 1 comma 1, 2 comma 2 and 3 comma 3. It is a must. Why it is a must? Because it has to be reflexive. And by the condition of the question, I should have 1 comma 2 and 1 comma 3. Why should I have 1 comma 2 and 1 comma 3? But that is what is asked in the question. 1 comma 2 and 1 comma 3. Now, is it reflexive? Yes, it is reflexive. Is it symmetric? Definitely not symmetric. Why? If 1 comma 2 is there, I should have 2 comma 1. If 1 comma 3 is there, I should have 3 comma 1. Correct? Now, is it reflexive? Yes. Is it symmetric? 100% yes. As of now, it is symmetric. Now, is it transitive? That's a question. 2 comma 1. Yeah, I got it. 2 comma 1 belongs to R. 1 comma 3 belongs to R. 2 comma 1 belongs to R. 1 comma 3 belongs to R. Definitely 2 comma 3 does not belong to R. So this is I've given you a counter example of a relation which is reflexive, it is symmetric but not transitive. Okay. And if I look for R2, see this is 1 comma 1, 2 comma 2, 3 comma 3. I should have 1 comma 2, I should have 1 comma 3, I should have 2 comma 1. Okay, I should have 3 comma 1. Okay, but what will happen? This will be the same example as R1. So what I have left out? I have left out 2 comma 3. If I add 2 comma 3, what will happen? This will be reflexive, but it will not be symmetric. If you want to make it symmetric, I have to add 3 comma 2. Now, this is reflexive, this is symmetric, but it is also transitive because this is nothing but A cross A. Okay? So, you cannot have R2. So, there is only one relation which is reflexive and symmetric but not transitive. Now, in this problem, I also want to highlight one important fact. So, when you are talking about a set A which is having say 1, 2, 3 elements, okay, 1, 2, 3 elements, understand the smallest equivalence relation will be 1, 1, 2, 2 and 3, 3, and the largest equivalence relation will be A cross A. Let's go to the next question. This is again an NCERT question. A is 1, 2, 3. Find the equivalence relation containing 1 comma 2. So what is R? R, definitely you should have 1 comma 1. You should have 2 comma 2. You should have 3 comma 3. And you should have 1 comma 2. Why should I have 1 comma 2? I should have 1 comma 2 because according to the question. So if you had 1 comma 2, it cannot be symmetric. So to make it symmetric, I will add 2 comma 1. Correct? To make it symmetric, I have to add 2 comma 1. Now, is it reflexive? Yes. Is it symmetric? Yes. Is it transitive? 1, 2, 2, 1, 1, 1. Yes, perfect. This is an example of a relation which is reflexive, symmetric and transitive. So it is an equivalence relation which has 1 comma 2 in it. Definitely 1 comma 2 must be part of the set. Now this is R1. Is it possible to have any more relation? This is something that you need to examine. I don't know. You have to examine. 3 comma 3. Definitely you should have 1 comma 2. Why should I have 1 comma 2? If you don't have 1 comma 2, then you are violating the question. The question says your relation should contain 1 comma 2. If you want to have 1 comma 2, you should have 2 comma 1. Otherwise, the symmetry will be lost. And if I stop here, then there is no difference between R1 and R2. So I need to extend my set. How do I extend? Add any element you like. I add 3 comma 1. The moment I add 3 comma 1, is it reflexive? Yes. Is it symmetric? Definitely no. Why it is not no? Because I have 3 comma 1. What should be there for symmetry? I need 1 comma 3. I need 1 comma 3. What now? Is it reflexive? Yes. Is it symmetric? Yes. Is it transitive? Is a question mark. It is definitely not transitive because 2 comma 1 belongs to R, 1 comma 3 belongs to R, but 2 comma 3 does not belong to R. So if you want to make it transitive, and if I had 3 1 and 1 3, I should definitely add 2 comma 3. If I add 2 comma 3, problem. It is reflexive but not symmetric. How do you make it symmetric? by adding 3 comma 2. Now what is left for me to add? Nothing. So I have, this is my A cross A. So these are the two examples of relations for this particular condition, which is an equivalence relation. Therefore, the answer is option B. There are two such relations. Now let's go on to the next question. What is this question all about? Let R be a relation on R. R, this is real numbers, okay? Be a relation on R defined as defined by A comma B belongs to R if A square minus 4AB plus 3B square equal to 0. Okay. Now how do I understand this? How do I do this problem? Now let's talk about reflexive. Before that, let's see the definition. These are my definitions, right? I have it with me, so I'll keep it here. Reflexive. Reflexive means how many elements I should choose. I should choose one element for every A belongs to real numbers. I need to verify this. I need to check whether A comma A belongs. So wherever A, B is there, replace it by A. So I get A square minus 4 A into A plus 3 A square. What is that? 4A square minus 4A square, which happens to be 0. So it satisfies this condition. Since it satisfies this condition, I have A comma A belongs to R. If every element is related to itself, then you can say R is reflexive. I can say R is reflexive. Now you have to go for symmetric. Now how do I go for symmetric? I will take one example. I will take 3 comma 1 belongs to the relation R. I will take 3 comma 1 belongs to relation R. That means what? 3 square minus 4 into 3 into 1 plus 3 into 1 square. What is that? 9 minus 12 plus 9, which is 0. Therefore, this condition is true. But 1 square minus 4 into 1 into 3 plus 3 square, plus 3 into 3 square. What is that? 1 minus 12 plus 27 is definitely not 0. This implies 1 comma 3 does not belong to R. Therefore, R is not symmetric. Look at the definition. Therefore, R is not symmetric. Now I have to go for transitive. Well, I can remove this. It's not required for me. Now transitive. Now what example? I'll choose an example. Now what example will I choose? I'll choose 9 comma 3 belongs to R. I'll choose 9 comma 3 belongs to R and 3 comma 1 belongs to R. Obviously this is 9 square minus 4 into 9 into 3 plus 3 into 3 square. So 9 is 81 minus 108 plus 27. So obviously it is 0. So this relation is true, correct? And this relation is also true because I have here. You can always write that there, okay? Now what I want to prove is, I want to check for 9 comma 1, does it belong to R or not, right? So 9 comma 1 means what you'll do? 9 square minus 4 into 9 into 1, 4 into 9 into 1 plus 3 into 1 square. So this is 81 minus 36 plus 3, which is definitely not 0. Therefore 9 comma 1 does not belong to R. So 9 comma 3 belongs to R, 3 comma 1 belongs to R, but 9 comma 1 does not belong to R. Therefore R is not transitive. Now let's go to the next question. Show that the relation R on set of all natural numbers cross natural numbers, and it is defined as a square plus b square equal to b square plus c square. We have done similar questions before. Okay, so let's see how to go about it. Reflexive. For every a comma b belongs to n cross n. Now what I need to prove? I need to prove that a comma b is related to a comma b. Now how is the relation defined? The extremes are added and squared and added, and the mean is again square and added. So it will be basically, you should have got in the previous step a square plus b square, a square plus b square equal to b square plus a square, which is so obvious because they are all real numbers. So a square plus b square should be equal to a square plus b square, and by commutative property you have b square plus a square. So it satisfies this condition. Therefore a comma b is related to a comma b. Therefore R is what? R is reflexive. There is no question. Now is it symmetric is something that you need to verify. Symmetric. For every a comma b and c comma d belongs to n cross n, what happens? If a comma b is related to c comma d, that means what do you know by the definition? A square plus d square equal to b square plus c square. B square plus c square. What I want to prove? I want to prove c comma d is related to a comma b. That means what I should have proved? I should have proved c square plus b square equal to d square plus a square, right? This is what you should have got so that you can write this. So for this to be possible, all that you need to do is just swap the place. B square plus c square equal to a square plus d square. A equal to b, you can write b equal to a. Now by commutative property, b square plus c square is c square plus b square. A square plus d square is d square plus a square. Hence you prove it. Now, all are natural numbers. Therefore R is symmetric. Wonderful, isn't it? Now let's go to transitive. For transitive, how many elements I should choose? For every a comma b, c comma d, e comma f belongs to n cross n. What do you know? If a comma b is related to c comma d and c comma d is related to e comma f, that means what do you know from the definition? It is a square plus d square equal to b square plus c square. All this as 1. Then c square plus f square equal to d square plus e square. All this as 2. Now what do? You add them. You add 1 plus 2. When you add 1 plus 2, you get a square plus d square plus c square plus f square equal to b square plus c square plus d square plus e square. So d square gets cancelled, c square gets cancelled, you get a square plus f square equal to b square plus e square. Obviously this is a comma b is related to e comma f. You can check it. See, a square plus f square equal to b square plus e square. Therefore R is transitive. Since R is reflexive, symmetric and transitive, what type of relation it is? R is an equivalence relation. Isn't it? Very, very simple. You have done similar questions like this in the previous videos. So you can refer to that. Now, this is again a very, very important type of question. This is an NCERT worked out example question. R1 and R2 are equivalence relation in a set A. Show that R1 intersection R2 is also an equivalence relation. So let's talk about reflexive. For every R1 R2 equivalence relation on a set A. For every A belongs to, or I will say what I will say here. In a set A, okay, belongs to set A. Now I have to prove that A comma A definitely belongs to R1. Why? Because R1 is reflexive. And definitely A comma B will belong to R2. Why? Because R2 is reflexive, because R1 and R2 are equivalence relation. Since R1 is reflexive, R2 is reflexive, I have A comma A belongs to R1, A comma A belongs to R2. If you have an element common in R1 and R2, I will say common. Common means what? A comma A, it belongs to both. Both means intersection. So you have proved that A comma B belongs to R1 intersection R2. This implies R1 intersection R2 is reflexive. Clear? Now let's go to symmetric. For every A comma B belongs to A, if A comma B belongs to R1 intersection R2. If A comma B belongs to R1 intersection R2, what you can say? Since it belongs to the intersection, it should belong to both R1 and it should belong to R2, correct? It should belong to both. Now, if A comma B belongs to R1, by symmetric property, B comma A will belongs to R1, and definitely B comma A will also belong to R2. Since B comma A belongs to R1 and B comma A belongs to R2, you will have B comma A belongs to R1 intersection R2. This implies R1 intersection R2 is symmetric, isn't it? Because R1 and R2 are equivalence relation, so it has to be reflexive, and now I am using the property of symmetric. Now let's go to transitive. For every A comma B comma C belongs to set A, if A comma B belongs to R1 intersection R2 and B comma C belongs to R1 intersection R2. This implies A comma B belongs to R1 and A comma B belongs to R2. And from here you have B comma C belongs to R1 and B comma C belongs to R2. Now what I will do, I will group this and this. A comma B belongs to R1, B comma C belongs to R1. Since R1 is transitive, can I say A comma B will belong to R1 intersection R2? A comma C will belong to R1 intersection R2. Next I am going to club these two. A comma B belongs to R2, B comma C belongs to R2. What you can conclude? You can say A comma C belongs to R1 intersection R2. In fact, this is, let us go one by one. This is R1 and this is R2. Okay, from this statement it belongs to R1. From this statement it belongs to R2. Now you can say that I try to write together, not necessary. R1 intersection R2. This implies R is transitive. Once it is reflexive, symmetric and transitive, R is what type of relation? It's an equivalence relation. Is it clear? Very, very simple. It's an NCERT worked out example problem. Okay, very, very important. It has come in the board. It came recently this year also in the board exam. It's a very, very important type of question. You should be very careful with this problem. Now, what is the relation? The relation is defined like this. If you choose two elements from real numbers A and B, he says that the relation is A minus B plus root 3 must be irrational. A minus B plus root 3 must be irrational. I want to know whether it is a reflexive, symmetric and transitive. So first I will take reflexive. For every A belongs to set R, set of all real numbers, you know A minus A plus root 3 a minus a plus root 3, which is root 3, which is definitely irrational, correct? Root 3 is irrational. Therefore, a comma a definitely belong to the relation. This implies R is reflexive. Understood? A minus a. A and a gets cancelled. So you get root 3. Always choose any element. If both the elements are same, you will get only root 3. Root 3 is irrational. Therefore, this is an example of a relation which is reflexive. Let's talk about symmetry. Let me take an example. Root 3 comma 2 belong to relation. Root 3 comma 2 belongs to real numbers, where root 3 comma 2 belongs to the relation R. That means what? Root 3 minus 2 plus root 3, which is minus 2 plus 2 root 3, is definitely irrational. This is definitely irrational. But you see, 2 minus root 3 plus root 3, if I interchange the position, you see you get 2, which is definitely not irrational. Therefore, 2 comma root 3 does not belong to R. Therefore, R is not symmetric. It is not symmetric. It is not symmetric. Now, let's go to transitive. For transitive also, we need to give an example. What example will I give? I will take 2 comma 2 root 3 belongs to R. 2 comma 2 root 3 belongs to R, and 2 root 3 comma, I'll take another example, root 3 belongs to R. Let us see whether this is true. 2 minus 2 root 3 plus root 3, which is 2 minus root 3, definitely it's irrational. Then 2 root 3 minus root 3 plus root 3, so it is 2 root 3, which is also irrational. So this is true. Now we can see 2 minus root 3 plus root 3. 2 minus root 3 plus root 3 is 2, which does not belong to S. It is not irrational. Therefore, 2 comma root 3 does not belong to R. See, 2 comma 2 root 3 belongs to R. 2 root 3 comma root 3 belongs to R, but 2 comma root 3 do not belong to R. Therefore, R is not transitive. I gave one example. You can come up with any example you want. It's very, very important type of questions. Okay. In fact, this is a very, very important question. Don't ignore these problems. Now let's go to this question. I have 2 more questions to go. Let's finish it off. Let S be set of all points in a plane. R is a relation defined as R equal to A comma B, such that A square plus B square is symmetric but neither reflexive nor transitive. We'll find out. Let's talk about reflexive. For example, let us take 1 comma 1. It's a point, correct? 1 comma 1 is a point in a plane. Belongs to A. So I'll call A as set of points in a plane. I have taken 1 comma 1. So 1 square plus 1 square is definitely not equal to 1. Therefore, 1 comma 1 does not belong to R. This implies R is not reflexive. Yes or no? R is not reflexive. Now, let's talk about transsymmetric. If I choose A comma B in a set A, if I choose A comma A and B, okay, if I choose points in a plane, A comma B in a set A, if you have A square plus B square equal to 1, that means A comma B belongs to R. Definitely B square plus A square will also be 1, correct? That means B comma A also belongs to R. Therefore, R is symmetric. So this is reflexive, but it is not symmetric. So this is not reflexive, but it is symmetric. Now, how do I prove it's transitive? Let us choose 1 comma 0, and I'll choose 0 comma 1. You see, 1 square plus 0 square is 1. 0 square plus 1 square is 1. But 1 square plus 1 square is not equal to 1. Therefore, 1 comma 1 does not belong to R. R is not transitive. Correct? See, 1 comma 0 belongs to R. 0 comma 1 belongs to R. But 1 comma 1 does not belong to R. A very simple example of a relation, simple example to demonstrate that it is not transitive. So this is an example of a relation which is not reflexive, but it is definitely symmetric, but it is not transitive. Very simple questions, but you need to think for these problems. So let's go to this last problem. Take set of all points. I'll choose A as a set of points in a plane. Now what is the question? If you choose any 2 points, the distance between them is less than 2. The distance between them is less than 2. Let's see. Let's talk about reflexive. For every set A belongs to the A, A minus A, distance between A and A will be 0, is always less than 2. Therefore, A comma A belongs to R. Therefore, R is reflexive. Therefore, R is reflexive. Now, is it symmetric? Very simple. Symmetric. For every A comma B belongs to the set A, if A comma B belongs to R, that means what? Distance of A and B is less than 2. Definitely distance of B minus A will also be less than 2. This implies B comma A also belongs to R. Distance between A and B is 2 meters, means distance between B and A also will be 2 meters. So it is not going to change. Therefore, this is definitely symmetric. Okay. And last one, transitive. And let us see how we verify whether it is transitive or not. Suppose if I choose 3 points A, B and C belongs to the set A, if the distance between A and B is less than 2, distance between B and C is less than 2, that means A comma B belongs to R and B comma C belongs to R. Okay, we can even imagine as a triangle, yeah, A, this is A, B, this is A, B and C. The distance between A and B and distance between B and C will always be greater than the distance between A and C. So in general, you can say there may be cases where it may be less, but distance between A and C cannot be less than 2. Okay, distance between A and C cannot be less than 2. So what if they all lie in the same straight line? If this is less than 2, this is less than 2, this will be less than 4. So definitely A comma C does not belong to R. Therefore, R is not transitive. Okay. So with that, we completed all the problems which I wanted to do in relations. So this is my last video on relations. From tomorrow or from the next video, we will be doing problems from functions, which is also very, very important. So I have covered almost all types of questions that is required for you to write the board exam, whether it is 1 mark or a 2 mark or a 3 mark question as far as relations is concerned. Next video we will be putting on functions. Okay, kindly subscribe to my channel and also click the bell icon and continue your support. I hope these videos are useful to you. If you have any questions or query, please put it in the comment section so that I can get back to you. Have a lovely day. See you then again in the next class. Bye bye.